The information in this video comes from thorough research. Please share your thoughts on the video Galileo Galilei, revolutionizing science in the comments. We'd love to hear what you think. All truths are easy to understand once they are discovered. The point is to discover them. Galileo Galilei. Galileo Galilei stands as one of the most transformative figures in the history of science. Often referred to as the father of modern science. His work laid the foundation for modern physics and observational astronomy, challenging centuries of traditional thought and reshaping humanity's understanding of the universe. Born during the height of the Renaissance, a time marked by renewed interest in art, literature, and intellectual exploration, Galileo's contributions helped ignite the scientific revolution, a period that would ultimately redefine the relationship between science, religion, and society. Galileo's significance lies not only in the discoveries he made, but also in the methods he used to arrive at them. At a time when science was largely based on philosophical reasoning and inherited wisdom from ancient authorities such as Aristotle and Ptolemy, Galileo insisted on observation, experimentation, and mathematical analysis. He was among the first to rigorously apply the scientific method, carefully formulating hypotheses, conducting experiments, and using precise measurements to test his ideas. Through his telescopic observations, Galileo revolutionized humanity's understanding of the cosmos. He provided compelling evidence that celestial bodies were not perfect and unchanging as previously believed. His discovery of Jupiter's moons, the phases of Venus, and the rough surface of the moon directly contradicted the dominant geocentric model of the universe, which held that Earth was the center of all celestial motion. Galileo's vocal support of the heliocentric theory proposed by Copernicus, that the Earth revolves around the Sun, would eventually bring him into direct conflict with the Catholic Church. Galileo's life is a compelling story of brilliance, courage, and controversy. He was a man who dared to question the unquestionable, to challenge the intellectual and religious orthodoxy of his day, and to pursue truth through empirical evidence. Despite facing censorship, trial, and house arrest, Galileo's work endured and ultimately triumphed. His legacy has inspired generations of scientists, philosophers, and free thinkers, and his name remains synonymous with the pursuit of knowledge against all odds. This comprehensive examination of Galileo Galilei's life, work, and influence will explore his early years, scientific discoveries, personal struggles, and the enduring impact of his ideas. Through a detailed analysis of his achievements and challenges, we will gain insight into the life of a man who changed the world by daring to look beyond what was known and by insisting on seeing with his own eyes. Early life and education. Galileo Galilei was born on February 15, 1564, in the city of Pisa in the region of Tuscany, which was then part of the Duchy of Florence in Italy. He was the eldest of 6 or 7 children in a middle-class family. His father, Vincenzo Galilei, was a music theorist, composer, and lute player who held progressive views on science and art. Vincenzo was a vocal critic of Aristotelian thought in music theory, and his intellectual independence had a lasting influence on his son. Galileo's mother, Giulia Monati, came from a noble but impoverished background and managed the household while supporting her husband's and children's pursuits. From an early age, Galileo exhibited a keen intellect and curiosity about the natural world. Although his family was not wealthy, Vincenzo ensured that Galileo received a proper education, recognizing his son's potential. Galileo's early education began at home and continued at a monastery school run by the Camaldolese monks at Vallombrosa, east of Florence. There, he was introduced to classical literature, Latin, and religious studies. For a time, Galileo considered becoming a monk, but his father, concerned about the limited prospects and influence of a monastic life, withdrew him from the monastery and steered him toward a more practical career. In 1581, at the age of 17, Galileo enrolled at the University of Pisa to study medicine, following his father's wishes. Medicine was a respected and lucrative profession, and his family hoped that Galileo would secure a stable future. However, Galileo soon found himself more interested in mathematics and natural philosophy than in anatomy or Galenic medical theory. He was captivated by the works of Euclid and Archimedes, whose writings introduced him to geometry and the principles of mechanics. Galileo's academic shift from medicine to mathematics was solidified through his interactions with court mathematician Ostilio Ricci, who recognized his exceptional talent. Under Ricci's mentorship, Galileo began to conduct his own investigations into geometry, motion, and balance. One of his earliest and most famous observations reportedly occurred in Pisa's cathedral, where he noticed the rhythmic swaying of chandelier and began to investigate the principles of pendulum motion. Although the details of this story may be apocryphal, it illustrates his early inclination toward observation and quantification of natural phenomena. Despite his growing passion for mathematics, Galileo did not complete his medical degree. Financial difficulties forced him to leave the University of Pisa in 1585 without a diploma. Nevertheless, he continued to study independently and began writing treatises on topics such as hydrostatics and motion. His reputation as a brilliant thinker began to spread, and he soon attracted the attention of scholars and patrons throughout Italy. Galileo's early years were characterized by both intellectual restlessness and a deep commitment to understanding the world through observation and reason. Unlike many of his contemporaries, he did not accept received wisdom uncritically. Instead, he questioned established authorities, both scientific and philosophical, and sought to test ideas through experimentation. These qualities would come to define his scientific career and place him at the forefront of a transformative era in human thought. Academic and professional career. Following his departure from the University of Pisa in 1585, Galileo embarked on a period of independent study and teaching that would lay the groundwork for his future scientific achievements. During this time, he supported himself by offering private lessons in mathematics and began to write about his observations in mechanics and natural philosophy. His first known work, a treatise on the center of gravity in solids, attracted the attention of scholars in Florence and Padua and helped establish his reputation as an innovative thinker. In 1589, Galileo was appointed to the chair of mathematics at the University of Pisa. This position provided him with a modest salary and a platform to develop and share his ideas more formally. It was during this period that he began challenging Aristotle's long-held views on motion. According to Aristotelian physics, heavier objects fall faster than lighter ones, but Galileo conducted experiments, most famously involving balls dropped from the Leaning Tower of Pisa, to demonstrate that objects fall at the same rate regardless of mass, assuming air resistance is negligible. Though the tower experiment itself may be more legend than fact, his rejection of Aristotle's teachings and reliance on empirical evidence marked a revolutionary departure from traditional science. Galileo's questioning of Aristotelian physics earned him both admiration and controversy. His work was often met with resistance by those who adhered to scholastic methods that favored philosophical deduction over observation and experimentation. This tension would characterize much of his academic life. In 1592, Galileo accepted a more prestigious and better-paying position at the University of Padua, part of the Venetian Republic. He held the chair of mathematics there for 18 years, a period he would later describe as the happiest and most productive of his life. Padua offered a relatively liberal intellectual environment, and Galileo flourished both as a teacher and as a researcher. He gave lectures on geometry, astronomy, and mechanics that were widely attended, and he began to attract the patronage of powerful individuals, including members of the Venetian Senate. During his time in Padua, Galileo conducted experiments in dynamics and developed key concepts related to motion and mechanics. He studied projectile motion, acceleration, and the behavior of inclined planes, laying the foundation for the later development of classical mechanics. He also invented a military compass that could be used for calculating angles, distances, and fortifications, a tool that further enhanced his reputation and financial stability. In addition to his scientific work, Galileo became increasingly involved in the design and improvement of scientific instruments. He built early versions of the thermometer, which he called a thermoscope, and refined instruments for measuring time and motion. His improvements to the telescope, however, would become his most famous and consequential contribution. Although he did not invent the telescope, Galileo was among the first to grasp its potential for astronomical observation. In 1609, after hearing reports of a Dutch invention that magnified distant objects, he constructed his own version of the telescope, gradually improving its magnification power to up to 30 times. Galileo's telescope would soon transform not only his own life, but the entire field of astronomy. In 1610, he published Sidereus Nuncius, the Starry Messenger, a short treatise that described his telescopic observations of the moon's craters, the countless stars of the Milky Way, and the 4 moons orbiting Jupiter. These discoveries offered direct evidence against the Aristotelian and Ptolemaic models of the universe, which held that all celestial bodies revolved around the Earth and that the heavens were perfect and unchanging. The publication of the Starry Messenger brought Galileo international fame. He was lauded by scientists and courtiers alike, and in the same year, he was appointed chief mathematician and philosopher to the Grand Duke of Tuscany, a position that allowed him to return to Florence with a generous salary and increased prestige. However, his rising prominence and bold challenges to orthodoxy would also draw the attention and eventual opposition of the Catholic Church. By the end of this phase in his career, Galileo had moved beyond being a university teacher to become one of the most influential scientific minds of his time. His ability to fuse theoretical insight with experimental rigor and practical invention set him apart from his contemporaries. His academic journey, from Pisa to Padua to the Medici court, reflected a trajectory shaped by intellectual courage, innovation, and an unyielding belief in the power of empirical observation. Inventions and contributions to physics. While Galileo Galilei is widely remembered for his astronomical discoveries, his most enduring contributions may well lie in the field of physics. Galileo fundamentally altered the understanding of motion and mechanics, paving the way for later thinkers like Isaac Newton to develop the laws of classical mechanics. Through a combination of theoretical insight and innovative experimentation, he laid the foundation for modern physics, especially in the study of kinematics and dynamics. The thermoscope and temperature measurement. Among Galileo's earliest inventions was the thermoscope, a forerunner to the modern thermometer. Developed in the late 1590s, the thermoscope operated on the principle that air expands when heated and contracts when cooled. It consisted of a glass tube with a bulb at one end, partially submerged in water or alcohol. Changes in temperature caused the liquid to rise or fall in the tube. Although it did not have a numerical scale and was therefore unable to give exact temperature readings, it demonstrated that temperature could be measured by physical means rather than sensory perception. This invention marked an important step toward the development of quantitative scientific instrumentation. The law of falling bodies. One of Galileo's most revolutionary insights was his challenge to the Aristotelian belief that heavier objects fall faster than lighter ones. Through careful experimentation, often using inclined planes to slow down motion and measure time more accurately, Galileo discovered that objects of different masses fall at the same rate in a vacuum, a conclusion that was entirely at odds with centuries of accepted thought. He formulated the law of uniform acceleration, showing that the distance an object falls is proportional to the square of the time it has been falling, is proportional to superscript 2. This discovery became one of the cornerstones of classical physics and is still taught in physics courses around the world. Galileo's use of mathematical formulas to describe physical phenomena marked a significant shift in scientific methodology, away from qualitative descriptions and toward precise quantitative analysis. The concept of inertia. Galileo was also instrumental in developing the concept of inertia, which would later be formalized as Newton's first law of motion. He observed that a body in motion tends to remain in motion unless acted upon by an external force, an idea that contradicted Aristotle's view that continuous motion required a continuous cause. Galileo illustrated this principle through thought experiments, such as imagining a ball rolling down one slope and up another. If the second slope were gradually flattened, The ball would roll further and further until, on a flat surface, it would continue indefinitely unless something stopped it. This concept helped displace the ancient belief in natural and violent motion and laid the groundwork for the Newtonian framework. Projectile motion. In his studies of ballistics and the motion of projectiles, Galileo was among the first to realize that the path of a projectile is a parabola, not a straight line or a combination of vertical and horizontal motion as separately defined by earlier thinkers. He understood that the horizontal motion of a projectile was uniform, constant speed, while its vertical motion was uniformly accelerated due to gravity. The fusion of these two types of motion into a single, mathematically defined trajectory was a major breakthrough in understanding real-world physics. This was not merely a theoretical insight. Galileo's understanding of parabolic motion had practical applications in military engineering and artillery, fields in which he also offered instruction. His work on projectile motion represented one of the earliest examples of applying mathematics to describe complex, real-world phenomena in a coherent and predictive manner. The pendulum and timekeeping. Another of Galileo's significant contributions was his study of the pendulum. Observing the regular swings of a chandelier in the Pisa Cathedral, Galileo noted that the period of a pendulum, the time it takes to complete one swing, depends primarily on its length, not on the weight of the bob or the width of the swing. This led him to discover the principle of isochronism, meaning that the pendulum's period is constant regardless of amplitude, within small angles. Although Galileo never built a functioning pendulum clock during his lifetime, he conceptualized it and left detailed notes, which were later used by others to create timekeeping devices based on his principles. The pendulum clock would eventually become the most accurate form of timekeeping for centuries, revolutionizing navigation, astronomy, and scientific measurement. The principle of relativity. In his later work, particularly in Dialogue Concerning the Two New Sciences, 1638, Galileo introduced an early version of the principle of relativity, which stated that the laws of physics are the same in any system moving at constant speed in a straight line. He used the example of a ship's cabin to explain that an observer below deck would not be able to tell whether the ship was stationary or moving uniformly on calm seas. This concept would much later become a central tenet of Einstein's theory of special relativity, but its origins can be traced back to Galileo's clear reasoning and insistence on empirical evidence. Astronomical discoveries. In 1609, Galileo heard about a Dutch invention that could magnify distant objects. He quickly built his own improved version of the telescope, eventually reaching up to 30x magnification. This tool opened the heavens to human observation in a new way. With his telescope, Galileo made several discoveries that challenged traditional cosmology. The moon. He observed mountains and craters, proving it was not a smooth, perfect sphere as Aristotle had claimed. Jupiter's moons. In January 1610, he discovered 4 moons orbiting Jupiter, now called the Galilean moons, demonstrating that not all celestial bodies revolve around Earth. The Milky Way. He revealed it was made up of countless stars, previously invisible to the naked eye, sunspots, and Venus phases. These further supported the Copernican heliocentric model, showing that the heavens were not unchanging. His 1610 book, Sidereus Nuncius, Starry Messenger, made him famous but also drew opposition from the church. Galileo's findings provided strong evidence for the heliocentric model and disrupted centuries of geocentric belief. Conflict with the church. Galileo's support for the Copernican heliocentric model increasingly put him at odds with the Catholic Church. In 1616, church authorities declared heliocentrism formally heretical because it contradicted Scripture. Galileo was warned not to teach or promote the idea. Despite this, he continued his research and writings. In 1632, he published Dialogue Concerning the Two Chief World Systems, which defended the heliocentric model through a fictional debate. Though framed as a neutral discussion, the work clearly favored Copernicus and indirectly mocked Pope Urban VIII, a former supporter. This led to a formal trial by the Roman Inquisition in 1633. Galileo was found vehemently suspect of heresy and forced to recant. He was sentenced to house arrest for the rest of his life. His book was banned, and he was forbidden from teaching or writing about heliocentrism. Final years and legacy. Galileo spent his final years under house arrest at his villa in Arcetri, near Florence. Despite his confinement, he remained intellectually active. In 1638, he published discourses and mathematical demonstrations relating to two new sciences, which summarized decades of his work on motion and strength of materials. This book, smuggled out of Italy and published in the Netherlands, became a cornerstone of modern physics. His health declined. He eventually went blind, but he continued mentoring young scientists and corresponding with European scholars. He died in 1642 at the age of 77. Though silenced in his time, Galileo's ideas endured. His method of combining observation, experimentation, and mathematics shaped modern science. In 1992, more than 350 years after his trial, the Catholic Church formally acknowledged its error in condemning him. Galileo is now remembered as a father of modern science, whose courage and brilliance changed humanity's view of the universe. Galileo Galilei was more than a scientist. He was a visionary who challenged centuries of established belief through observation, reason, and bold inquiry. His work in physics, astronomy, and scientific methodology laid the foundation for modern science and inspired generations of thinkers. Despite facing powerful opposition and personal hardship, he remained committed to seeking the truth through evidence. His legacy endures in every scientific discovery that values critical thinking, observation, and the courage to question authority. If you have any experiences related to this topic, be sure to share them with us. Until the next episode, be mindful of the energies around you.